All right, welcome to part 2 of the 7.4 quadratic equations and vertex form notes. So we've gone over our intro to vertex form, which is this right here. You know what, let me just clean this up a little bit, make this a little bit prettier. There we go. Okay, so intro to vertex form is done. Let's go over how we go from vertex form, which I want you to write this. I want you to get used to like knowing what this looks and feels like. Vertex form, which is y equals, you're writing this, a times the quantity x minus h squared plus k, where a is the same as it usually is, and then h comma k is our vertex. To get that into standard form, which is y equals ax squared plus bx plus c, we simply need to simplify. So you can see here that like I've got a lot of operations to do. I have to do x minus whatever h is, then I've got to square that, then I'm going to multiply by a, then I'm going to add k, and I did those in the order of operations, by the way. And then when I do all of those operations in order, I will end up with standard form, which is simplified because none of these are like terms. So this is as simplified as it gets. So bottom line there, to get from vertex form to standard form, we simplify, which means that we follow the order of operations, or PEMDAS. Okay, quick reminder, if you have not done PEMDAS in a while, parentheses. So like if there are like terms in parentheses, then we can go ahead and combine like terms first, and then exponent, and then multiplication and division from left to right, and then addition and subtraction from left to right. Okay, so here, in this case, we will be looking to see if these are like terms, and if they are, we'll combine them. Then we'll be squaring that. Then we'll be multiplying that by a. Then we'll be adding whatever the k is. So let's see that in action. All right, I'm gonna start with number 3. So first of all, I want to know what the vertex is. Hopefully you watched part 1. If not, go back and watch it if you're confused on this one. But the vertex is going to be, flip this to +1, comma, keep this at -8. So this is a vertex at 1, comma, -8, which I can get from vertex form at the very, very beginning. All right, now, this wants me to convert to standard form by simplifying. So first we identify the vertex, check, and then rewrite it in standard form. So we're gonna use PEMDAS. Okay, so first of all, parentheses. I'm looking inside my parentheses. I've got my x minus 1. Are those like terms? Well, no, because this has an x and this one does not. So parentheses, can't really do anything there, check. Now I'm gonna look for an exponent, which I do see right here. So what does it mean to square something? Hopefully you're saying it means to multiply something by itself, like how 3 squared is 3 times 3, and 5 squared is 5 times 5, and so on and so on. Here, there's no shortcut here. I have to actually multiply x minus 1 by itself in order to square it. And then times technically negative 1 on the outside, and then -8 on the outside. So this came with me, and this I'm actually going to multiply by itself in order to square it. So let's go ahead and do that. We have -1 times, I get x squared, minus 1x, minus 1x again, and then plus 1, because -1 times -1 is +1. And then end parentheses, -8. Okay, it's very important there that I keep my parentheses here so that -1 gets distributed to every single part of it inside. So before I do that though, now I do have like terms in my parentheses. So I'm gonna go ahead and combine like terms first. I've got -1 times x squared, then that combines to -2x, plus 1, minus 8. So I have officially squared my x minus 1. Now I'm going to multiply. Let's distribute this -1. And then it does not get distributed to -8. No. So here we get -1x squared plus 2x minus 1, and then that minus 8 comes with me. Last but not least, I'm going to combine like terms again, and I'm going to get negative 1x squared plus 2x minus 9. So you can see that that is in standard form because I have an A, B, and C. So my vertex form, or sorry, my standard form is negative, I'm going to go ahead and leave out that 1. So I'll just say negative x squared plus 2x minus 9 is standard form. Okay, I want you to go ahead and try number 1 and number 2 by yourself, and then come back to this video and check and see if you got the same thing that I did. So I'm going to work these out real quick silently, but I want you to work them out by yourself first and then press play. I'll start with number 1. Okay, so I technically have a 1. So parentheses, not like terms, done. Exponent, yes. So I'm going to have 1 times x minus 4 times itself, and then plus 5. Oops. Okay, so I have 1 times, oops, x squared minus 4x minus 4x plus 16, and then, oops, plus 5. Okay, lucky, because this won't even affect anything. Oh, but I should combine like terms first. So I have 1 times x squared minus 8x plus 16 plus 5. Okay, so here, that multiplying by 1 will not change anything. So I have x squared minus 8x plus 16 and then plus 5. Combine like terms one more time. X squared minus 8x plus 21. So x squared minus 8x plus 21. Oops, and I forgot to find my vertex from the very beginning. It's going to be positive 4, positive 5. Okay, I think I said I was going to do that silently, and I definitely was not silent. So hopefully you paused me, and hopefully you got the same thing that I did there. Let's do it one more time on number 2. G of x equals 3 times the quantity x plus 2 squared. Once again, these are not like terms. I'm going to just go ahead and start by squaring this. So I've got 3 times x plus 2 times itself. So that's 3 times the entire quantity of x squared plus 2x again plus 4. Okay, let's combine like terms. So I have 3 times x squared plus 4x altogether plus 4. And then now I can distribute, and I've got 3x squared plus 12x plus 12. 3x squared plus 12x plus 12. Okay, oop, I forgot to put my vertex again. Okay, it's going to be negative 2, comma 0. Okay, and we can prove that the vertex form and standard form of each function above are equivalent functions 2 main ways. The first way, graph them both. They should, or I should say, let me be specific, the parabolas should be the same. So I'll show you what that means, like a number 3. So I can write the h of x, but I don't need to. I'm going to be lazy. I have negative 1 times x minus 1, quantity squared, minus 8 looks like, oops, this in blue. Now my answer was this. So I have negative x squared plus 2x minus 9. I'm going to change that to red so it's really obvious. Okay, and you can see that they are the exact same parabola. So we are correct. So that's one way. Or we can plug in some number for x into both equations, and we should get the same output. So let me pull up my TI-84 for that. Slide over. I'll check number 1 for this one. So I'm gonna pick a weird number. I'll choose, I don't know, 13. 13 store in x. I've got quantity x minus 4 squared plus 5 gets me 86. And now my standard form was x squared minus 8x plus 21 also gets me 86. So I'm correct. Okay, so that is gonna do it for part 2 of 7.4 quadratic equations in vertex form notes. I will see you in the final part, part 3.